In this video, I'm going to talk about area between two functions or curves. Let me draw a diagram to kind of help you see things. So let's say this is my rectangular coordinate system, x and y. And let's say this is my function f of x, okay? And let's say this is my function g of x. These are just some two arbitrary functions, and my points of interest are, let's say, a and b, and I'd like to find the area between these 2 points. So area between these 2 points bounded by these functions, or the difference between, or area between these 2 functions, and let's call this area to be a. So I am interested in finding the blue shaded region. So now it's very easy to find. You just take the integral from a to b, f of x minus g of x dx. Now let's go ahead and look at it. Kind of a couple of assumptions I have made, which you probably guessed already. One is that f is greater than or equal to g for all x in this interval a comma b. That's one assumption. It's obvious from the diagram here. And also f and g are continuous on that closed interval. So these are the two assumptions that we need for this to be true, the integral. Now, of course, we want f and g to be continuous. We don't want any unexpected discontinuity, such as going to infinity or any of those, so that we can do the integration. Now, from a common sense point of view, this should make sense too. If I am trying to find the area between this curve and this curve, remember, if you were to take the integral of a function, let's say you take integral from a to b, f of x dx, it gives you the area between the curve and the x-axis. So this integral is going to give you blue shaded region and the green shaded region. However, the integral a to b g of x dx is going to give you only the green shaded region, this region right here. So if this integral is giving you blue plus green shaded region, and this integral is giving you only the green shaded region, so if you subtract the green shaded region, you're left with the blue shaded region, which is nothing but this integral. Now let me go ahead and give you an example, by the way, a very simple example and a popular one. Let's consider these two functions. So this is my rectangular / Cartesian coordinate system, y, and let's say this is my function y is equal to x square, and let's say this is my straight line y is equal to x, okay? Now I'm interested in finding this red shaded region. That means the area between these two curves. So let's go ahead and find this area. First of all, we kind of need to find the points of intersection where these two functions intersect. So that could be found very easily if I set x square is equal to x. So that is telling you that these two functions are equal to each other. So where are they equal? Where they intersect, right? So if I were to simplify it, I'm going to get x squared minus x is equal to 0. If I factor out x, that's going to give me x times x minus 1 is equal to 0. Now you're multiplying technically two factors or two numbers, right? And getting 0. So one of them must be 0. So we don't know which one is it. So we say, let's say x equal to 0. So great. What if x minus 1 is equal to 0? In that case, x must be equal to 1. So our points of interest, or points where these two functions intersect, so this one and this one intersect, are at 0 and 1, which you can see obviously right here and 1. This is pretty obvious, but I kind of wanted to show you just by setting up the equation and solve it when things are not so obvious. So let's go ahead and find the integral or evaluate the integral. So our integral is going to be this integral. So I'm going to write the lower limit at 1, upper limit at 0. My f of x is the bigger one, okay? So which is the top one, straight line. So I'm going to put x minus x square is the smaller function, dx. And if I were to integrate it, it's very simple. All of you know. It's going to be x square over 2 minus x cube over 3. This evaluated from 0 to 1. For 0, it's going to be 0, as you can see, right? So I can just ignore it. But for the other case, it's going to be 1 square over 2 minus 1 cube over 3. And then minus 0, by the way. Minus 0. If I were to simplify it, I'm going to get 1/2 minus 1/3, which is, by the way, 3/6 minus 2/6, which is nothing but 1/6. So this is how you find the area between two functions, okay? Area between two functions over some interval. I hope that this discussion was helpful. Thank you very much.